Hello, and welcome to a Mondays on Tuesday on Friday. I have been inspired. I am recording early. I'll probably release early, but want to get some thoughts down. I I I I've had a very interesting week, and it's full of realizations, and I want to share them as quickly as I'm having them. So today I'm going to talk about the hardest thing when it comes to selling my idea to existing engineers. I say existing engineers, meaning people who have been in the industry for a while. And I'm also going to talk about how I finally got down to why am I building this Caneka system? It sounds crazy to finally know what exactly I'm doing after 2 years of doing it. But the reality is I had an intuition. I knew something could be improved and what I was after and what I had seen work really, really well in an industry where there are not always things working well. And so what I'm going to talk about today is two things. One, the hardest concept to get through to people who have been programming for a while and working in tech, even as not necessarily programming, but close to defining the work or valuing the work. And then the clearest conceptual reason for why I am building Caneka. Usually when I talk to people and they have a hard time understanding what I'm doing and they find out that it's kind of like a programming language tool system, when they hear that word, they say, "Oh, you're writing your own programming language." Now I understand, and that's a fraction of what I'm doing. It actually does not have a language syntax yet, and the reason for that is that I really wanted to get down to the nitty-gritty nuts and bolts and understand why I felt like there was more power in humans using computers in some form of a definition language than I was seeing or able to do. There was a phrase someone said early in my career. Supposedly, it's a common German phrase, which transliterates into walking around the town with the church. And this is kind of a metaphor for something that's a joke or impossible. And the reason was that there were so many German towns that had church in the center that walking around the town with the church was kind of like a way of saying hyperbole or, baloney or, something like that. And I felt like we were walking around the town with the church while writing all these if statements and for loops and all these things. And I have struggled for so long to figure out exactly what it was that I was on about. And then the concept that I'm actually struggling to convey to other software engineers is it's going to be, I don't know, hopefully not as shocking as it is when I say this in person, but nobody cares about the insights. It's, people have lives to live, people have things to do, and the guesswork of, did you want this? We're going to show you this pop-up for this new feature, or we're going to compare you to these people and guess this, or my favorite thing to hate on is the ideal user behavior one, or, this reinforces ideal user behavior. It's like, I think when you're using the tools that matter, your phone, a calendar, a spreadsheet, maybe you're figuring out, where to drive, you have a thing to do that is far more important than you than a computer figuring it out for you. You know your situation better. And this one idea is so hard to get through in terms of product value. And then the templater that I have that I'm working on, it's working really well. It's a crazy complex concept, and the implementation is not so wonderful right now. However, it works enough for me to do some things with it to show some demos that I really need to, and it can be optimized later because it is such a simplistic concept, and I'll get into what that is. This may be a bit technical of a podcast, but it will have some metaphors in there that hopefully have some meaning. The concept that I am working to wipe away from languages is multiple argument single return, because it's so seductive to think that you can reduce complex things into simple things. But realistically, life is more like an ever-changing mess, and so are the systems we model with computers. With that, the music will play, and then I'll talk about it. first want to give a shout out to all the wonderful people that I have spoken to today. Today was a day of networking with internet friends between bouts of coding. And I just feel like, for the longest time I was, it's nothing like in-person socialization. And for the longest time I was socializing, with the people at my co-working space, and that's wonderful. I've made many, many connections, some real deep, good friendships. And I heard someone, I think it was on a podcast, but I forget which one, talking about how at times when the people who know you and are more inclined to be afraid of the risks you're taking than supportive, the answer to that is internet friends. I thought about that. And so I joined a lot more conversations on LinkedIn and started making connections and finding, um, basically like the equivalent of like Friday, hot mess, things are exploding discussions and various people who have wonderful coffee chat, open calendarly, calendar-ish things. And I've talked to a lot of people, and it's been so refreshing because, I've known for a while that there are a lot of us in this sort of white collar workplace refugee status kind of thing. People say that, those people keeping their jobs are doing so because they don't want to face the 18-month job hunt. And if someone had said that to me or to anyone around me, a few years ago, it would raise some eyebrows of like, what are you doing wrong in your job hunt? Because I was used to the 2-week job hunt where I would get, I mean, this was like, I don't know, late 2010s in New York City, and I would get upset with a company, contact a bunch of recruiters, walk across the street, have a few interviews, and I was out of there. I was not a admirably behaved employee, and I don't recommend you do this, but I was so badly behaved that I would actually just start disappearing once in a while uh, for interviews. Like in the middle of the day, I would just leave the office and nobody would know where I was. And it was so efficient that by the time they got around to firing me, I already had a job offer. Like by the time they realized I was missing, I had a job. That's how fast things were moving as a software engineer at that time. And so to hear the idea of an 18-month delay, and I experienced that. I mean, I did a 1,000 or more application, 3 or 4 month job hunt 2 years ago, or well, it was about a year and a half ago. It was I think the late spring of 2024. Yeah. And that was enough for me to be like, okay, something is wrong. Something is very, very wrong. And now 18-month job gap. Yep, that's the expectation. So I've connected with a lot of people who are, not in living conditions they expect, not, as connected as they remember, not, and not with the income they expected. And it's really, really nice to connect with really, really like-minded people, even if we're all sort of hanging out on the fringes and the edges of the world. So shout out to that. It's been wonderful to meet people and talk about things that can be done, things that we're concerned about. And one of the things that comes up with other software engineers is an extreme distaste for the way things have gone. But there's this misconception that it wasn't really a functionality problem with these companies. And I think, yeah, sure, there's greed in the world, there's mismanagement, those kinds of things. But to the extent that companies base their valuation on reading people's minds and proposing things to them, I think that's a pretty clear indication that those companies are going to go underwater, and I think that's what's happened. Um, I I know a lot of things I use that don't function quite right. I know a lot of people who would like them to work better, and I think there's real money in that, and so that's one of the reasons for my optimism. To the technology that I am building that I expect to be the leverage to sort of rebuild all this stuff, and I've talked a bit about functional profitable teams and how I'd like to build multiples of them and get people back to work and stuff like that. Well, what exactly am I on about with this crazy technology? So I've had a few projects where I was kind of a fly on the wall. I kind of realized early on that my opinion was not really jiving with the team architecturally, and so I just kind of sat back and watched. And I think this was like a multi-year period of my career where I just kind of became apathetic because I was so tired of being shot down. And what I noticed a lot of was that teams and the business was not particularly good at defining what they would commit to as an unchangeable thing, the kind of thing that you like, pour in concrete because you're never going to change it and you can commit to it and do it in a way that, it's not the kind of thing you need a ton of flexibility in. And then make sure that like something you would analogously say is like the door hinges of the system, the kind of like places where users make a lot of changes or there's a lot of different, varied requests that come in. Focus a lot on the flexibility of those things. Maybe there's a dependency injection approach at that time. Maybe there's a configurability. Maybe it has like kind of like a routing table so that you can like mix and match elements really fast, which usually has a performance cost. But if there's a flexibility value of the business, rock on. Um, and I don't think that definition was particularly well done at times. And so we ended up having like, you do something in a week and then they'd say, cool, do it 4 more times. And it would then take a week and a half the second time, 2 weeks the third time, 4 weeks the fourth time. And the reason for this is that it wasn't built with the flexibility in mind of the kind of request darts that were getting thrown at it. And so going in there, it actually got heavier and heavier and heavier and harder to do, kind of like working in, I don't know, a big tub of molasses or quicksand instead of the sort of accelerated, well-oiled machines, prepared kitchen equipment, ball bearings in the wheels that need to turn, that kind of thing. And so I feel like this accelerant approach within the business cases that you expect things to be thrown at is a very important part of profitability for a software company, satisfaction for the software engineers working on it, pride in estimates for the product owners managing it. Like it's pretty important to have things get easier as you go instead of harder. And later in my career, I had one massive project where I was greenlit to do exact like whatever I wanted, and I built this insanely configurable system that ended up actually causing some political problems at the company because it was such a alien working style that when other engineers came back into the code, they were like, "What in the world did you do?" And what I had done was, kind of like the door hinges analogy where things can move, open and closed, but times a lot. I mean, there were really a lot of for loops in this thing. It was digesting basically I mean, this sounds awful because it was awful. I basically wrote a domain-specific language inside of like a 3,000 line JSON file, and the keys of the JSON file were triggering various behaviors, and that's messy. I didn't expect anybody to read it. I was told there would be a user interface that would generate these things, and that was then cut from scope, and so we were all drowning in this horribly defined JSON file. It was not one of my brightest decisions, but I have been building language tools from scratch, and so I'm basically I built the memory manager and the garbage collector. I built, the flexible array structure. I built the string system and string library. I built a hash table, which is like a key value store, and then I built, a cursor and parsing engine and kind of a function dispatching extensibility framework. And then on top of that, I built a class system and a way of optimizing the static offsets of the classes and the class members so that you don't have to use, string key lookup. And then I built a templater that caches all of that in real time so that polymorphically similar objects basically can be reduced to numerical offsets so you don't have the expense of calculating their position in a more complex data structure. And then on top of that, I did a bunch of Unixy stuff for, file and buffer input output and a bunch of network stuff for a web server that pulls the file descriptors similar to like libevent. And I realize this is all a whole bunch of tech jargon, but the interesting thing about all of this stuff is that a lot of it was writing and rewriting and rewriting. A lot of this stuff's done as like, I don't know, 8th to 12th generation. And I would say convincingly that every generation before that was not good. And what I say by generation is like I would write something to the point where it functioned and then delete it because something wasn't right. Something was incongruent, something didn't line up, something didn't match, or it was just like super confusing to work on. And what I have found through very successive generations of different things is that the more I work on the system, the more I really get down to what makes a language function and what contributes to some extent to language dysfunction. is I'm oftentimes holding state within the object types, and my system actually has 16 bits of stateful flags on every object, which sounds odd if you're in the, immutability space of sort of functional programming, or even if you're in the object-oriented space of, data locality or, one-way data flow, and there's value to absolutely all of those things. The reason why I have 16 bits of statefulness in every single object is because I generally felt the need to return stuff as making new stuff from memory just to return the status of something seemed a bit wasteful. And it's turned out to be wonderfully performant memory-wise not to have that. Having, combinable flags. I think there's one object that uses that space as a numerical range that would be non-combinable. But for the most part, it's 16 bits that can only be 16 values. Not needing to manufacture those state variables has been wonderful. And the more I played with it, the more I realized, the real value here is to have an object that you pass in as like a contextual object, which is not a huge deviation from what you have in a language like Python, where you're passing, the object in as the first argument, the self argument. And if it's a class level method, you're passing in the class. And so that idea of a context is pretty interesting. And when you write in the C language and you're doing anything object oriented, you're doing that by default because there's no like this context like you have in Java, or even in JavaScript, where it represents the calling function. And then in JavaScript and TypeScript, you have the fat arrow, which repositions the context to whatever you were outside of. That's like the enclosing context. So many languages have this idea of a context that you're going from. I mean, even like very modern systems like React have the whole hook system where you're use state, or it's been a while, so I'm not going to remember all the names, but someone was telling me there's a modern contexty thing where you can pull the context of the page or something, and that just, it seems functional, and I'm not in any way surprised that particularly front-end language frameworks that need to respond to all kinds of things have gone in that more contextual direction. And so I noticed over time building these tools with all these different use cases and needs for functionality that 9 times out of 10, my functions returned something kind of unnecessary. And it got to the point where I would have a context object that I was passing in that would be storing the results of everything and have, 16 bits of statefulness that was defining the next step to take. And I slowly realized that what I was actually so obsessed with configuration systems and properly contextual systems, or state machines that weren't awful to work with because they had, properly defined positions things could be in and they were understandable. I've grown to realize that it's possible the largest barrier to functional programming languages is the mistake that multi-argument single return functions are helpful conceptually. And if you've been writing software for a while, you will understand how deep of a challenge this is into the software world, because you more or less have to go either into GPU programming, which is programming on graphics cards, to get away from this, or you have to go all the way down to assembly to get away from this concept. Because when I look in depth at how a compiler like Clang or GCC or CC, or any of the other ones, um, when I look in depth at how they form stacks and stack frames, and how the Linux low-level APIs work, I spend most of my time working in FreeBSD, but I believe their system call architecture is somewhat similar, though. When I was writing assembly, mostly just for educational purposes, I was writing ARM assembly on a Raspberry Pi, and understanding those system calls was quite possibly the most educational moment of my entire computer science experience. And what I started realizing is that most system calls are, about like this. You have a bunch of registers in the CPU, you load them up with numerical arguments, and then you load an argument somewhere in the CPU that's basically the do stuff call. So I'm going to register, the file open call or the copy call or the write call or the move call or the start process call or the send kill signal call. And then I'm going to put in the register that, handles all this kind of stuff, the go call. And the go call is going to read the other registers and do something. And when code is compiled into the most common format is an ELF binary, ELF, and I don't actually know what that stands for, or even really what that means, other than it creates the binary code that is then used to create the stacks and the functions and all those kinds of things. The model that I understand is that the body of the function is pushed onto the stack, and any variables specified as needed by that function is then also pushed onto the stack. I'm not sure if it's in that order or the opposite. And then the function will run, and when the function is done running, it will place the result argument also on one of those variables that's allocated as the stack. So what this essentially looks like is if you have an argument that takes 4 arguments, maybe a pointer to a context object, you know, a 64-bit number, uh, and a pointer to like a C string, that's 0 terminate or whatever. And then if your function body, has a bunch of pointers it needs or whatever, so that whole set of, arguments and then the whole set of variables you have inside of the body, there's going to be space made for that on the stack, and then over the behavior of the function, they'll get filled. There's nothing about this model that doesn't allow for the allocation of multiple arguments that you will then reference after the function finishes, except for one thing, which is the ability to decrement the stack counter uh, down to clean up the value, the amount of stuff you've put on the stack frame. So if you were to say, you know what, this function returns 4 things or 5 things or 10 things, the question invariably becomes, okay, but when does it get cleaned up? Because if it's undetermined where that stuff is going to be used, it ought to be on the heap, which is usually on the opposite side of the memory allocation. So the heap is like when you malloc something and you basically just don't define when you're going to use it. And it's considered one of the most dangerous, though necessary things to do, because if you don't clean up that memory, nothing will clean it up for you. But conceptually, there's kind of a insidious arrogance to this idea that you can allocate variable slots for a number of things and expect that the reduction into one thing is actually what you need. Because I don't believe that's how the world works. I mean, if you go to a restaurant and you order food, or if you buy a car, or if you order a package, like, I don't know, from a like, let's say a beauty store, you order, a bottle of shampoo. There are a number of steps that go to assembling that product, and when you receive it, when you receive the meal, when you drive the car off the lot, when you receive the package with your shampoo, there are many different things that have gone into making it a singularly representative thing to you. The meal is on likely one plate. The car is likely in one piece, let's hope, that you can drive. Um, and that bottle of shampoo is in packaging that comes in, one unit. It's not like, they give you the bottle and then they give you the box the bottle was in, and like it's not like, you go to buy a car and they give you the steering wheel and then they give you the brake pedal. And, that's not how we think about the world. We think about the world in terms of finite points in time, fixed destinations, complete deliverables. But the process of making these things is quite the opposite. At the time of assembling the car, there are robots screwing in all 4 wheels at the same time, or, soldering the body onto the frame, in multiple places at once because the robots are doing it all at once. Likely, I've never built a car, I don't really know, but I'm imagining if you're cooking, you're likely mixing multiple ingredients at a time, and you're using the heat threshold to cook multiple things at a time. If you're adding a meat and a spice into a sauce, like a tomato sauce or a cream-based Alfredo sauce, you're doing it at the same time because the same heat that you're using can cook both of them. It can integrate and break down the proteins in the meat. It can ingest the flavors of possibly, fresh or powdered garlic into the sauce. And I think that to the extent that programming is seen as a single deliverable that a user will use, there is value to this many things become one model. But well, the sausage is made. I actually think it's the wrong idea. I think we've kind of gotten spoiled with the belief that we can chunk together computer science problems into, convenient little, boxes with a tied bow on top where you can send it a mess and it sends you back clarity. And send it a mess and it sends you back clarity. You can do this multiple times, and maybe you're making a mess of all these send mess, bring clarities back. That's totally possible. But I think it's much more likely that actually modeling the world has to do with stacks and queues and status combined of multiple things, which I realize is the many to singular model. But the stacks and queues model, where you've parsed something, you push that onto a stack, you then make sense of it in context to other things, and that then is made sense of in context to other things as well. That has struck me over the time writing this Caneka system as a much more valuable way of looking at functional systems. Much more like the car that is being assembled in multiple places, almost like thinking of it like a Formula One pit crew where you drive in and there's one guy with the pump lever pushing it up from the bottom. There's, a team on each wheel, switching them out, and there's one person fixing the front fender, and or, cooking where, you throw a bunch of things in the pot and you're mixing it all at once and it's all cooking at once. And so the way the Caneka system is designed, the memory manager is what I call place dump, which is kind of a variation on mark sweep. Um, Basically, it grabs a page and then fills up the page, and then if it needs another page, it fills up another page. And if it needs a temporary page for stuff that it's expecting to discard quickly, it can increment the temporariness of the memory chapter and allocate those pages. And then when the task reaches a point where it says, I no longer need pages with temporariness above this value, those all get placed what I call in the recycling, which means they are allocated as no longer part of the memory chapter and they're set to be wiped. And when they're wiped, they'll be reallocated to the next task that requests them. And deviating from reference counting was wonderful because reference counting has this really nasty thing as I was writing it, where because you're decrementing the reference count and it will reach 0 at any time, that means that if you have a bug in your memory manager, that bug will explode on you at any time. So in addition to the fact that there's a ton of calculation in reference counting memory managers, place dump made sense. Now, in addition to this place dump memory manager, the span architecture, which is the flexible array, which one day I'll go to some lengths to document because I find it fantastically interesting. On top of that is the iterator that goes along in these like slabs and some powers of 2. Right now it's 16, could be 32. But basically they scale in powers of that amount. So if it's 32, you start with a slab of 32. If you need more than that, you end up with 32 times 2. Um, Actually, that's not accurate. You actually end up with 32 times 32. I'll go to the number I have that I'm using now because I'm using 16, and that goes 16, 256, 40, 96. I should probably check my code to make sure those numbers are accurate, but that's the kind of scalability that it has. It goes from small to very large very quickly. And I end up much more often finding value in adding to and utilizing an existing structure of data than I find from this sort of reduction of single return. And I feel like I'm kind of, I don't know, talking in circles at this point in the podcast, but I wanted to share that I had discovered an actual reason for what I was building. And I think the reason is that we have accepted into our model of computer science that a function signature convention that was created in the C language is in fact the most sensible way to do things. And and I'm at a point where I believe that it is the most sensible place to end up in the end, which is some singular deliverable. But I'm now incredibly excited about what these syntaxes on top of Caneka can be. I'm guessing they're going to be more in the direction of Lisp, but hopefully without some of the memory constraints that came with Lisp. I heard back in the day it was one of the most popular languages among computer scientists. However, they kind of ran out of runtime space to run the systems at a certain level of complexity. And so I am just, I don't know, absolutely excited about what can be done with systems that kind of handle and represent the sort of messiness of real world challenges. So, true to form here at Mondays on Tuesdays, I'm going to leave things a little bit open, but hopefully as the demo runs, I'll have documentation that can absolutely back this up, because I think that the idea of, embracing the mess where it is, and especially with the move to GPU programming that we've seen, where you're parallelizing vectors of information and running them over separate kernels. And the most popular front-end framework, React, has also moved towards a hooks-based, I realize that's not a concept, that's actually just their name for the API calls, but a hooks-based model that is fantastically flexible. I think that there is some tremendous value in leaving this idea of multiple arguments, single return, and moving more in a direction of stacks and queues to get to a place where the intuitiveness of developing software and having conversations about what software could do can really sort of match the pace that we've grown to expect from software. And as always, as I sign off, if you're excited about the things that I do, things that I talk about, the things that are going on with Compare Basic, head on over to comparebasic.com. And if you're interested in this particular system, it's all documented at caneka.org. And hopefully by the time you hear this podcast, I will have a functional template system that I can show off why I'm so excited about stacks and queues, because they just make a simplistic way of discussing what's going on. It's kind of like you can begin to explain things almost visually rather than super technically. And that's refreshing.